is being recorded.
Hello everyone. Let's continue with the waste management lecture, the second part, the wastewater treatment. The main objective of this lecture is to understand the principles of a wastewater treatment plant process with individual components. So you have to understand wastewater treatment plant designs may vary depending on the requirements, depending on the financial situations, depending on the climatic conditions. So what I'm trying to explain in this lecture is the typical systems that are there for different removal processes of wastewater components. So the actual design itself may vary depending on certain factors. So before we go into the discussion, let's have a look at this video. So let's look at what is wastewater. Wastewater can be defined as the water that has been used from any combination of domestic, industrial, commercial, or agricultural activities. Even surface water, storm water, and any other sewer inflows to sewer infiltrations can be considered as wastewater depending on the specific setup. So in some wastewater treatment plants, only the institutional and the wastewater is only considered in the treatment facility, whereas sometimes we consider the combined sewers also taken into the wastewater treatment. And if you really look at what is wastewater, as a result of domestic, industrial, and commercial activities, the discharge water after the consumption of different activities can be considered as the wastewater. And when we look at the characteristics of wastewater, depending on the use, from where it is being discharged, the characteristics may differ. However, if you take the discharges from domestic and municipal wastewater, and also considering specific communities, we can have a certain specific characteristics for the treatment, typical characteristics for this wastewater. But wastewater coming from industrial applications, different industries, they may have their wastewater depending on the process that is being used in the industry. So it's very specific to the industry itself. So in this discussion, we will mainly focus on the municipal wastewater, that is wastewater coming from uh, houses and general institutions, but not special industries and so on. So generally, if you can look at the wastewater, it can be categorized into uh, three main types of pollutants, uh, like physical, chemical, and biological pollutants. Right. So when we look at the domestic wastewater, we can have two main categories of for the wastewater. That is wastewater coming from toilets uh, and so on, which is called the black water. Right. So this basically this is the wastewater component, which is relatively more polluted. And the grey water is the water which is coming from rest of the activities in the domestic area, including washing, bathing, and kitchen wastewater. But this component comprise relatively low pollution, but in larger quantities. Now, when we look at how the wastewater is managed in today's context, we can see there are on-site treatment such as use of septic tanks, soakage pits, etc. And on-site treatments are basically individual for each house, based on individual house, we can see. And decentralized treatment, that is for building clusters or housing clusters, you will have a single treatment plant. So unlike each household having on-site treatment, maybe a small community can get together and have a single decentralized system. And they are relatively maybe in medium size. And centralized treatment, it is for a larger community, where you will collect wastewater from a large extent, certain area as you see. So in the uh, video, so you collect from a large catchment and then treat centrally at single place. So that is central treatment. We can look at the wastewater characteristics, and we can divide them into three different main groups. So if you look at the components such as the parameters that we can characterize the wastewater, we can see there are in the wastewater microorganisms, and there are biodegradable organic material, and there can be other material which may not be biodegradable readily. There are nutrients such as nitrates, phosphates, especially from the domestic sewage. You have it's very nutrient rich, and when you consider the municipal wastewater, you don't have much of metal compounds because we are excluding the industries. But sometimes, even today, we see certain domestic uh, solvents, cleaning agents we use may contain some of the metals. And it can be other inorganic material, and also depending on the temperature of the water, we can also identify the effect of, we would say, thermal effects, and also we can see color, and radioactive parameters can also be there. So why these different wastewater constituents or elements are important for us? Because it may have human as well as environmental impacts. Now, with respect to the different uh, wastewater constituents such as microbiological parameters, or especially the microorganisms, they can cause different diseases due to the pathogenic bacteria and viruses which comes with the wastewater. And if you release the wastewater into the environment, the contamination of the microorganism with these pathogenic bacteria and viruses can cause health impacts. Then the biodegradable organic material uh, in wastewater, why we have to treat and remove the biodegradable organic material is they are oxygen depleting material. If you release directly into the rivers or the lakes, it will have biological oxygen, biochemical oxygen demand, and deplete dissolved oxygen in the water bodies. And similarly, the organic material and nutrients will pollute the surface water bodies, and especially the nutrients would lead to the status of eutrophication, which is the enrichment of nutrients, which will lead to algal blooms. And significance of metals, especially the heavy metals, are bioaccumulators. So once released into the environment, they can enter the food web and have detrimental environmental as well as health impacts on the human beings. And similarly, the other parameters. Now, what about the thermal pollution? If the wastewater is warm and hot, if you release the warm water into the environment, especially the rivers, streams, and reservoirs, uh, you can harm the natural flora and fauna balance in these systems. So that is why we need to treat wastewater to remove these unnecessary elements. Right. So as I indicated, uh, to avoid decaying of organic substances in wastewater, once it is released into the environment or surface waters or soil, uh, you have to treat the wastewater. And also excessive nutrients in the environment lead to the problems of eutrophication, and it will lead to the degradation of the total environment. Also, we identified the importance of treatment with respect to the health impacts to make sure the communities are staying safe and safeguarded against the health impacts. We need to treat the wastewater. Similar to what we saw earlier, we can characterize the wastewater using different parameters. Broadly, we can categorize the wastewater into oxygen demanding material, mainly the wastewater containing carbon compounds, and the nutrients, especially containing NNP, that is nitrogen and phosphorus compounds. Wastewater contains pathogenic substances and suspended solids, and this will mainly due to the waste containing carbon and inert material. And we can also see the endocrine disruptors chemicals, which will include a different set of PCBs, dioxins, and so on. Then in the modern wastewater, we can also see the pharmaceutical byproducts, which is being mixed with wastewater, and also personal care products. So now we are a bit clear about the wastewater treatment goals. So why we need to treat wastewater is we need to manage water discharge from the domestic business environments and industries to reduce the threat of water pollution. But in our discussion, we will exclude the industries and businesses and only concentrate on domestic wastewater. So when you look at the large-scale wastewater treatment plants, which are centralized systems, you can see these 5 distinct steps of wastewater treatment. The wastewater will undergo the pre-treatment process, then it will enter the preliminary treatment, and then it will go into the primary treatment, secondary treatment, and finally the sludge treatment. So the key objectives, as I indicated, we will know, you will be able to describe how wastewater is collected and transported to treatment plant, and you should be able to indicate the functions of each treatment option process and describe the methods that we have for effluent disposal. Right. So in the wastewater treatment system, we can specifically identify the wastewater treatment plant, and before we bring the wastewater to the wastewater treatment, you have to collect it from a specific household in the upstream. So for that, you need a collection system. A collection system will typically comprised of a pipe network where you will collect the wastewater from your catchment. So in these collection systems can be of three types mainly. We can have only the sanitary sewer lines, that is the wastewater collection pipelines from the household. And of course, you know, in a community, you have to have a sewer system, and sometimes, depending on your treatment design, you can combine the sewer system to the sanitary sewer lines as well. But in modern wastewater treatment plant, we tend to separate the sanitary sewer systems and will not go with combined sewer system. So you can see certain component in the collection systems. You will collect the wastewater mainly through gravity from your catchment. You will have a set of manholes, and the manholes will be connecting to the gravity sewer line. Now you see, depending on the ground profile or the terrain, you won't be able to continue with gravity sewers all the time. So depending on the type of terrain, you may have to have pumping stations to lift the flow and bring it to another higher level. Yeah, you can see here. So pumping will put the water into a higher level, and from that point onwards, you can promote gravity sewer. So whenever possible, you don't want to waste unnecessary energy for pumping stations, and that will increase the cost of treatment, and we will promote gravity sewer lines whenever possible. So you can see this is the system I was talking about. You have to collect your wastewater through a pipe network, and then you need to divert the wastewater into the wastewater treatment plant. So typically these are the steps as I indicated in a wastewater treatment plant. So we will look at each step one by one. So during the preliminary treatment, we mainly focus on physical treatment options, which includes screening, grit removal, pre-aeration, and flow metering and sampling. So we need to understand we may or we may not see all the components in a typical preliminary treatment. It will depending on the situation, we can optimize these steps. The primary treatment, the main focus is to remove, now in the preliminary treatment, our main target is to remove larger particles that are coming with wastewater. It can be large debris to small grit particles. In the primary treatment, the target would be to remove the particles that could not be removed during the preliminary treatment, but relatively small particles which can be removed through sedimentation and flotation mechanisms. Then the wastewater moves into the second treatment where mostly we select biological treatment options like using, there are different treatment options, you can use chemical-based treatment. Biological treatment is typically conducted in secondary treatment. And after this biological or chemical treatment, you will have sedimentation to separate, sedimentation tank to separate the solids from the liquid component. And then after the treatment, in the secondary treatment, mainly to remove biochemical oxygen demand, that is BOD, then you have to remove the nutrients such as nitrates and phosphates. So you can see after the secondary treatment, the tertiary treatment can be conducted too. In modern treatment plants, sometimes you can see the secondary treatment is combined with the tertiary treatment. So BOD removal and nutrient removal is combined. Okay. The final step of treatment is disinfection. That is removal of pathogenic components from the wastewater. Then finally, you will have to look at the treatment of solids as well, because in the treatment process, you will create solid part of waste as a byproduct of treatment. So the finally we have to look at the solid treatment through different techniques such as solid digestion. Right. Yeah, let's go into the details of each treatment step. In the preliminary treatment, as I indicated, we would have screening with removal, aeration, and uh, flow metering. That is to know what is the flow that is entering the treatment facility. As I indicated, the main objective is to remove large objectives. The main purpose is to protect the downstream pumps and equipment from damage. Otherwise, it will have excessive abrasion in the pumping and equipment. So main components you can see in the preliminary treatment are bar screens that will remove the different large debris, and then removal of smaller particles, the grit chamber. So this is a typical arrangement of the bar screens, and for specific designs you will have different types of designs for the bar screens. Then in the grit chamber, you will remove relatively small particles than at the barracks, and most of the time these particles that we remove in the grit chamber can be the inert, relatively big particles before we enter the wastewater treatment plant downstream of the wastewater treatment plant. Then you can see these are the key elements that we have talked about. You can see the bar screens here to remove the large debris, and then you have grit chamber to remove the finer debris. These are the flow metering components that we can see in the wastewater treatment plant most of the time. They are flow controlling devices where you can measure your flow into the treatment plant. So you can see the flumes right? This is a hydraulic structure where you will be able to measure your flow, and also weir systems. Again, this will help for us to measure the flow rates. Right. Then let's talk about the wastewater treatment and further downstream, in which you will make the flow measurements as I indicated, and then also sample the wastewater to characterize your wastewater at this stage before it enters further downstream. So these are some of the key parameters that we regularly measure at wastewater treatment plant. We will measure the suspended solids, we call it SS, and this will quantify the solid material into the wastewater treatment plant. And then we will measure biochemical oxygen demand, which is a measure of the amount of oxygen requirement in the wastewater. And, why we have to measure these two parameters specifically, it will reflect the effectiveness of wastewater treatment in the process. So at different processes, you will measure the wastewater characteristics with respect to suspended solids and BOD to monitor the wastewater treatment efficiency. So typically, both SS, that is suspended solids, and BOD should be reduced as we move on through the wastewater treatment process, as we can understand. In the wastewater treatment, primary treatment, after the preliminary treatment, water enters into the primary treatment process. In this process, mostly the physical processes will dominate. We will target the removal of further smaller particles through mechanisms such as sedimentation. It is, we try to settle the particles which can be settled readily from the wastewater. Right. So after the grid chamber, the wastewater enters the primary settling tank, or here you can see even we call it primary clarifiers, to remove the relatively smaller particles. As treatment techniques, you can have sedimentation tanks, that is, you tend to settle the particles, providing still conditions in the treatment basins, right? So that is vertically downward settling of principles. And also you can use the principles of flotation, that is, you are taking all the waste onto the top by providing air flotation. Right. Then, as I indicated, the main target of primary treatment is to remove the suspended solids and only a relatively smaller part of BOD removal. Then, whatever the settled material, we call it sludge, is removed from the system and sent to for further processing. So typically you can see this kind of structures as primary clarifiers, circular tanks, where you will introduce your wastewater centrally, right? You can see here, right? So wastewater will be introduced at the center and it will flow into the system, right? And then separate the water column and the sediments by the principles of settling. Then the water moves into the secondary treatment where your main target here is to remove the most of the BOD, the biochemical oxygen demand. And in secondary treatment, uh, it is a very common practice to see the biological treatment of wastewater uh, systems are being used. So chemical treatments are also available, but mostly for domestic wastewater, you can select biological treatment options which are relatively uh, easy to operate and sustainable options because we don't use hazardous chemicals. And the biological treatment is followed by sedimentation tank to remove or to separate the solid particles from the liquid particles. So we call this sludge, and we need to separate sludge from the rest of the water. So as I indicated, you can mostly see biological treatment processes associated with secondary treatment. Uh, so in the biological treatment, mostly what you focus on, we try to use the bacteria, fungi, and algae also in metabolizing the organic substances in wastewater in the secondary treatment. So there are different types of biological treatment facilities we can design, right? Uh, Now you can see after the primary treatment, the water enters the secondary treatment plant. From here onwards, it is secondary treatment. You can see here the trickling filter, that is secondary wastewater treatment option. Uh, you can see in many wastewater treatment plants. Uh, Trickling filter is a treatment technology where you will use microorganisms attached to uh, like particles such as gravel and rock particles, and you create a filter-like medium, but at the same time around this filter material you will have growth of microorganisms uh, as a slime layer, and the medium is stationary, and you will pass the wastewater through the stationary medium so that the during the travel of the wastewater through the filter medium, the water get treated by removing the most of the BOD, because the microorganisms attached to the medium will consume these organic substances as their food. And there are different other varieties of treatment options like rotating biological contractors. Again, a system where you keep the wastewater uh, without moving, but you will move the medium, right? Uh, these are some of the variants that we will not be going into details, right? But this is for you to understand. As secondary treatment, it is not only the activated sludge process that we have as an option to treat wastewater, right? So there are different variants of wastewater system designs. Here you will see a different variant, that is the activated sludge system. So in this system, there is no attached medium, but here the microorganisms and wastewater are mixed together and kept in suspension. Usually, if you talk about the strength of wastewater, we can see in sewage treatment, the domestic wastewater strength varies between 100 to 300 milligrams per liter of BOD. So typically, you can remove the relatively maybe 30 to 40% of your BOD until the primary treatment, but mostly the main component of your BOD is removed in the secondary treatment operation. And in the biological systems where microorganisms are utilizing the waste as the substrate or as the food, you need to provide the other favorable conditions necessary for the microorganisms to survive. In a natural system, what happens if you throw wastewater or maybe a piece of waste into a water body? Due to the oxygen, using the oxygen in this environment, if it is in a river system, the dissolved oxygen, the water, solid or the waste start decompose. So it will consume the oxygen and it will convert the BOD or the organic substances into inert material. So similarly, in the aeration tank, you have wastewater and the microorganisms in a suspension, in a together as a suspended liquid. What we will do is to enhance the biodegradation, you have to provide the right conditions. You have to provide sufficient oxygen. You have to maintain a favorable pH in this system. So once the water spends certain time, typically 4 to 24 hours in the aeration tank, water will be, or the whole liquid that will be it will move into the secondary clarifier. In the secondary clarifier, as we saw in the previous examples, the water is separated from the solids. So in the clarifier, you will get the clean water out, and then as the final step, you will apply the disinfection to kill any pathogenic organisms, bacteria present with the wastewater. So finally, it will go into the tertiary treatment to further remove the nutrients from the wastewater. So the nutrient removal can be achieved through different types of treatment options. Now, in the biological treatment, in the secondary treatment plant, you mostly used aerobic bacteria to remove the wastewater, the components in the wastewater, right? So aerobic bacteria is the bacteria that can decompose or break down the organic substances into inert byproducts in the presence of oxygen. In the phosphorus removal processes, or rather nutrient removal processes, we tend to use a combination of both anaerobic and aerobic zone. So we will not go into the wastewater microbiology, but we, depending on the terminal electron acceptance of the microorganisms, the microorganism diversity will change. So when you have plenty of oxygen, the microorganisms which can survive under the oxygen-rich environment will dominate. But when there is no oxygen, the terminal electron acceptor would be nitrates, components like nitrates and so on. So the microbial population will have a shift. The microorganisms which do not depend on oxygen will predominate. So in the nutrient removal, you would see the combination of uh, these two mixes of wastewater treatment. Uh, After the aeration tank, right, uh, we need to push the wastewater into the secondary clarifier. So after the separation of water from the solids, we need to get rid of the pathogenic compounds, if any. So disinfection is the process where we introduce the disinfectants such as chlorine, UV radiation, ozone to kill pathogens that is released after the secondary treatment operation. So the main objective is to remove the pathogenic substances. Then final step, that is the solid treatment. All the solids that is being generated during the treatment process need to be managed at the end by using the techniques such as digestion. The final step would be the disposal. So these wastewater treatment solids, the solids that is being arise from the wastewater treatment process, can be used as in agriculture if you don't have toxic material treated in the process, and as a soil conditioner, or maybe sometimes uh, as a fertilizer. So in the digestion, or we call solid stabilization, there are different other options that you can use. So these the treated solids can be used, or if you can't use it, if it contains hazardous material, your only option is incineration, right? And as treatment options, there can be other options such as oxidation, lime stabilization, uh, or post-lime stabilization, etc. So let's try to understand the process in bit more detail, right? Uh, so we talked about the wastewater pollutants uh, in the form of total dissolved solids, right? And total dissolved solid is a measure of the combined component of all inorganic and organic substances that may contain in the wastewater, right? And how we can measure the organic presence of organic substances in wastewater is through biochemical oxygen demand parameter, or BOD, and it measures the strength of any wastewater. So if you want to know your wastewater strength, the typical parameter that you would measure is biochemical oxygen demand, or BOD. And as we indicated, we try to remove the other chemicals and nutrients too. Uh, so how these different constituents are removed from the system? What is the transformation system? So the organic substances which contains mostly the carbon pollutants, carbon removal will happen by the conversion process into carbon dioxide. And how nitrogen is removed is again by converting into nitrogen gas. And the phosphorus is removed mostly as solids attached to the bodies of the microorganisms or cells, right? When you discharge the sludge, uh, part of phosphorus can be removed as well. Right. So this is a summary of what we have discussed, right? You will see uh, you will have a preliminary treatment, primary treatment process, secondary treatment. Mainly the biological treatment processes are used, such as aeration tanks and so on. And then you will have tertiary treatment, mainly targeting nutrients. Right. Let's look at the secondary treatment in a bit more detail. Uh, so as we indicated earlier also, the main treatment options we use in secondary treatment can be categorized as what you have seen here. We can use suspended solid processes, suspended growth processes, such as activated sludge process for removal of BOD. And you can see the trickling filters or biofilters. And again, you have other variants such as oxidation ditches, right? That is again suspended growth process. And also you will see rotating biological contractors. Again, as I indicated earlier, unlike in the activated sludge process, this is the opposite of it. The activated sludge, you will see both microorganisms and the wastewater are kept in the suspension. But here, the wastewater is uh, like it's not moving, whereas the medium is moving here, the biological contractors. We will not go into details of these different systems of treatment within the given time. We won't be able to do that. But we can see in wastewater treatment plants, we can have combinations of different secondary treatment options like we have discussed. So let's, since we are using living organisms for secondary treatment, removal of pollutants in the secondary treatment, we may also try to understand little bit of wastewater microbiology. So we will use different types of bacteria, fungi, protozoa, algae in the wastewater treatment. So with respect to the bacteria or the microorganisms, we can see in the wastewater, in most of the activated sludge processes, you can see heterogeneous microorganism populations dominate. So very briefly, in the presence of electron acceptors such as oxygen or nitrates, you have the food, which is the substrate. The microorganisms convert these organic substances into inert byproducts such as carbon dioxide and water, and release energy. And energy is carried forward and it will produce new cells of the microorganisms, right? So now these are the material that has been converted into new cells, the waste components using the substrate, more cells are generated. So this is how basically we get rid of the organic waste in wastewater, right? So the new cells will be settled down in the second treatment, and you separate the good quality water. Okay, let's look at different types of decomposition that we can see in the wastewater treatment. So mainly the secondary treatment plant, second treatment step. If we go for systems like activated sludge process, which I mentioned earlier, we use aerobic bacteria for the purpose. And especially in the nutrient removal, you can see a combination of aerobic and anoxic as well as anaerobic bacteria. And in the aerobic decomposition, right, as I indicated, the electron acceptor is mostly the oxygen, and the end products you can see carbon dioxide and water, and bacteria cells, which we settle down and separate. And if you look at the aerobic decomposition of wastewater, it is relatively odorless, right? Because it does not give rise to byproducts which can have a bad odor, such as sulfur dioxide and so on. And whatever the treated water is of good quality, and you can release to the environment without issue. Basically, the aerobic decomposition is targeting the wastewater with low BOD, right? So BOD around 100 to 300, it can be the best candidates for aerobic decomposition of wastewater. So aerobic systems can contain activated sludge and variants of activated sludge mainly. The anoxic decomposition, the electron acceptor is nitrates, and you will have nitrogen gas, carbon dioxide, and water and bacterial cells as byproducts. And in the anoxic decomposition also, you will see a relatively low odor. And a relatively safe disposal can occur into the ecosystem. So the main process that you can see in the decomposition of wastewater here is the denitrification process. Anaerobic decomposition processes, main electron acceptor is carbon dioxide and organic compounds. And you will create the byproducts such as methane, carbon dioxide, and water with the bacterial cells. And if you look at the odor, is relatively high because of the byproducts or end products that it may generate. And therefore, maybe you have relatively high potential for bad odors. And in the ecosystem, we will release in the treated wastewater. And here in the wastewater treatment, what kind of applications we use anaerobic decomposition is mainly sludge stabilization process. We can use anaerobic decomposition. So we know how the microorganisms, especially the bacteria, will live and grow. Right? So this is called the process of binary fission. That is, sorry, one microorganism becoming two, two becoming four, and so on. In microbiological wastewater treatment, uh, this is how a population would uh, have the biological growth curve, right? So in any population, you would have typically a slow growth rate in the initial stages, but with time it will pick up, right? So it will go into the long growth phase where the growth is quite rapid, and this is the growth phase that we target in wastewater treatment. Then it will reach a stable situation and it will start to decay. So this is typically the growth curve of any living being, including human beings. So let's look at how the wastewater, in wastewater, carbon get removed, right? So carbon characterized through biochemical oxygen demand uh, is converted into inert byproducts in the mainly during the secondary treatment. Uh, Now, what are the instances where BOD get removed? Now, usually you can see, as I indicated, about 30 to 40% of the BOD is removed in the primary treatment. And rest of the uh, removal will take place in the secondary treatment. So you can have a look at the explanation I have already explained, right? And nitrogen removal, as we indicated, right, uh, through tertiary treatment and the combination of anaerobic and anoxic treatment processes. Okay. So how the nitrogen is removed? Through the process of ammonification. So you don't have to go into more details, but I have kept this for your information. You can just have a look at this information, right? So all this I have explained earlier. This is for you to have a look and you can read. Right. So basically, in wastewater treatment plant, we emphasize the removal of organic substances and nutrients, mainly nitrates and phosphates, right? So in the wastewater treatment, we can have uh, more insight into the design and the treatment components, but within the given time frame, and our target is to look at the general overview of wastewater treatment. So these are some of the useful references that you can have, and thank you very much.